Okay.
All right. Hello, I'm Brad Peters, and we're doing vehicle networks. Um, and
Rader.
yep, and Tyler's here too. All right. So next slide. All right. So I'm gonna talk about the history of vehicular communication and van nets. So the idea of vehicular communication goes back to the 1970s when the US began to work on projects such as electronic route guidance system. This was a system that required a driver to enter a destination code into a vehicle system, which allowed the vehicle to communicate with an instrument's intersection where the destination code was decoded and gave the vehicle routing information. The term inter-vehicle communication, or ICV, began circulating in the 1980s. Currently, the term ICV has the same meaning as vehicle and ad hoc networks or van nets, and they could be used interchangeably. Early vehicular communication used various media such as lasers, infrared, and radio waves. You go on the next slide. The next big breakthrough in vehicular communication was between 1986 and 1997 when the United States began to work on the PATH project, which had the goal of using this advanced technology to increase highway capacity and safety. In Europe, they had a similar project called Prometheus from 1986 to 1995, which had similar goals. Around this time, many projects were implemented globally, such as the Advanced Safety Vehicle Program, Chauffeur 1 and 2, FleetNet, Car Talk 2000, and more. Okay, you go on the next slide. In 1999, the FCC allocated 75 megahertz in the spectrum of 5.85 and 5.925 gigahertz for intelligent transport systems, which plays a big role in van nets in the future. So the term vehicle ad hoc network, van net, um, was uh, was first mentioned in 2001 under the car-to-car uh, ad hoc mobile communication and networking applications, which referred to networks being formed and information being relayed among vehicles. Vehicle to vehicle and vehicle to roadside communication were shown to exist within van nets to provide road safety. Um, in this time, in the early 2000s, van nets were seen as a one-to-one application of mobile ad hoc networks, which were called man nets. And they used this idea and applied it to the vehicles. But you on the next slide. Yeah, and then in 2004, U.S. V2V standard, which is vehicle to vehicle, known as WAVE or wireless access for vehicle environments, built upon the lower level of the IEEE 802.11p. In 2008, European Commissions decided to use the 875 to 905 megahertz frequency band in order for transport safety ITS applications. You can go on the next slide. So then, more currently, in 2012, a pre-deployment project for V2X, which is vehicle to everything, was implemented in Ann Arbor, Michigan, with a project that involved 2,800 vehicles, which represented cars, motorcycles, buses, and HGV, which proved that it could improve this road safety and be improved by which no which improve which proved that road safety could be improved by this wave technology. All right, that's it. Thank you.
Okay, so I'm going to be talking about what do vehicle networks do and like what kind of features they share or provide. Some examples would be like traffic and parking management, and that would be accident avoidance, also known as collision avoidance, vehicular ad hoc networks or VANETs, the Internet of Vehicles, IOV, and then vehicles everything, as Brad mentioned earlier, V2X. Next slide. Okay, so traffic management. This works with the IoT and other things and applies it with smart cities to create a new platform called Intelligent Traffic Management Systems, or ITMS. This is a proposed system that would help resolve a number of traffic problems, such as like helping you predict the best route to get where you're going, and also reduces things like average wait time, traffic congestion, travel costs, and it helps reduce air pollution caused by cars. They use machine learning algorithms to predict like the best route based on uh, weather, traffic congestion, and many other factors. It also introduced this concept of a green corridor, which is allows emergency vehicles to just get where they're going without having to worry about traffic. Next slide. Okay. Accident avoidance is a driver-assisted system that uses sensors and algorithms to predict hazards and obstacles in the car's path to the driver to help them avoid collision. The warning could be audio, visual, or tactile, like a touch-based warning. They use this happens by using lasers and radar and cameras to detect objects. It also monitors other road users such as pedestrians, cyclists, and other vehicles. There's many different types of accident avoidance systems. The three most common the vehicle in front of you, so then it will let you know if you're getting too close. Emergency automatic emergency brake AEB. It will automatically brake the vehicle if it senses an object approaching the vehicle too quickly. And lane departure warning, which alerts the driver if they begin to drift out of their own lane. Next slide. Vehicular ad hoc networks, or VANETs, is a subclass of where it's developed by moving vehicles. Wireless multi-hub network, which has the constraint of fast topology change due to high mode mobility. This enables a high range of applications such as prevention of collisions. It improves safety, helps line crossing, has dynamic route scheduling, and it can measure real-time traffic condition monitoring and so much more. And Internet of Vehicles, IOV, refers to a network of different entities, such as vehicles, pedestrians, roads, parking lots, city infrastructure, and provides real-time communication among them. It's quite similar to IoT and other things in many ways. It also allows vehicles to exchange important information to one another, like efficiency, safety information, and with others using the nets. Next. And then vehicle to everything refers to vehicle and vehicle to infrastructure communication. It's a wireless technology aimed at enabling data exchanges between a vehicle and its surroundings. And by sharing this data, it assesses their position, their speed, and their surroundings to other vehicles and infrastructure and pedestrians. This can help improve driver awareness, potential dangers, and help to avoid any sort of collisions or fatalities that could happen otherwise. Next.
Okay, so I'm Tyler, and I'm going to talk about the vehicle network security. Um, Basically, what is vehicle network security? You want protection of the automotive networking infrastructure from malicious actors trying to access or modify the vehicle's data. It's extremely important data. Why is the security important? Because things like GPS, we have self-assisted driving, these safety systems that are in your vehicle, they're all transmitting safety critical data, and you don't want any of this data to be obtained by malicious actors or modified, um, because they're carrying precious cargo. They're carrying your kids and they're carrying everything. So then the vehicle networking has a lot of different protocols, as we know. Protocols are these rules on how your data is transmitted throughout the whole network. The goal of these protocols is successful data transmission while achieving data confidentiality, integrity, and availability. That's the CIA triad. That's one of the standards that most organizations use to base their security on. The CIA, confidentiality, integrity, and availability, extremely important security services that you should be able to obtain. Three main protocols that we're going to talk about is the CAN protocol. That stands for Controller Area Network, FlexRay protocol, and Automotive Ethernet. The CAN, Controller Area Network, it's a bus networking protocol. It's a method for communication for like smaller microcontrollers and electronic devices within a vehicle. This is early on. A lot of these microcontrollers and electronic devices are using this protocol. This is one of the first protocols that was ever invented for vehicle networks. Some security challenges that we have with this protocol, we have a shared broadcast network, which is extremely unsecure. We have no encryption. And due to the shared broadcast network, we have to worry about eavesdropping. Zero authentication needed for this data transmission. Malicious messages can be accepted as authentic in this protocol. Here we have the CAN bus with two control units between it, where you can see a malicious fuzzy control unit message is injected into the bus with no hindrance, no warning, no consequence. So next we have the FlexRay protocol, and this is really important for those safety critical systems. It's used for in-vehicle network safety critical communications. So think of brake-by-wire, power steering, driver assistance. These are all the systems that use FlexRay. FlexRay itself also doesn't use authentication. So you also run into the same message spoofing attacks. And you can also run into denial of service attacks where dominant bus signals are injected into the FlexRay bus, and that can cause a denial of service attacks. And these safety critical communications, they're prone to denial of service attacks. That's just a big yikes in the industry. And lastly, the most recent protocol we see is Automotive Ethernet. It's introducing the switch network that we're all used to into the automotive industry. A main challenge to this is the integration with all the other automotive networking protocols. How is the switch network going to interact with the buses from the CAN and FlexRay and all the other networking protocols there is in vehicle networks? The security challenges that automotive Ethernet faces is every main challenge that modern Ethernet also faces. Network access, you have to be able to configure ports with port security. Switching and routing configuration, you have to worry about traffic, integrity, and confidentiality, denial of service attacks, and replay attacks also. And then let's look towards the future. So what do you have? You have automotive cybersecurity solutions that are vastly improving year over year, but increased complexity is continuing to be a roadblock for proper security implementation. Everybody's worried about all the function that can be provided, and but nobody wants to care about the security, which is extremely important. You see in the information technology industry, everyone cares about the functions, how it works, but no one pays proper attention to the security. What to watch for in the future is how these engineers are going to take modern security solutions like IPS and IDS and make them work for the automotive use case. And then also to watch big Tesla, you have the autonomous driving, now those high bandwidth applications are properly secured. And then that's our references. Thank you, Dr. Tang. It was Tyler, Kaitlyn, and Brad.